Perfect. So yes, today we'll be covering payment gateways and what is involved in the system. Some of you would have already attended the class which we had. It's several months back. We had a class on design of UPI. So this was given by Shivam. Now this is kind of similar class we had on the design of UPI. You can check the channel to know about design of UPI. But yes, this is slightly different session because we'll be covering payment gateways like Paytm, and UPI is a different infrastructure. It is a government infrastructure hosted by NPCI, and that takes care of mapping between various VPAs, and Paytm is another independent private application or any other payment gateway, which could be Google Pay or Phone Pay. They will also have a similar scenario. They do support UPI, but they are basically a payment processor. So let me first start with some introduction about payment gateway. So today we'll be doing step-by-step designing of payment gateway, and this will help you to answer similar questions in a system design interview. We'll be covering a little bit of low-level design, but mostly we'll be focusing on high-level design. So payment gateways are required for any e-commerce application. So any e-commerce application you have, they need a payment gateway to process the online transactions. And most important requirement of payment gateways are they need safe and secure transfer of money, and the transfer of money happens between customers and merchants. So this is about payment gateway. So let me put down. So in e-commerce you will see, and this is having to do with mostly customer to merchant payments, right? So these are few of highlights of payment gateway system. Now coming to, let's take an example of Paytm, and let's discuss the design of payment gateway looking into the Paytm as reference. So if we look into the Paytm has following key functions, or any payment gateway, they have following key functions. So this is about functional requirement. First thing is you have to do payment processing, and the second part is payment confirmation. Now if I look into overall how does this happens, I'll just share briefly the system, or I would say very high level overview of how the payment gateways work. So you have customers who is visiting online store. So when a customer is placing order, you would have also done this in Amazon or any e-commerce site. Paytm is also an e-commerce site. You can buy some items. There is a Paytm mall, and you can book tickets, etc. But yes, mostly what happens when you confirm your order is the payment is the online store forwards the request to the payment gateway. Now payment gateway is responsible for validating the information, and it shares the information to payment processors. Payment processors are for example, MasterCard, Visa, UPI, various bank accounts, wallets will be there. So these are different payment processors. A payment gateway will forward the request to payment processors, and payment processors take care of communicating the information and making the bank money transaction happen. So the settlement between merchant bank account and customer bank account happens between the bank. Now these transactions takes few seconds and few minutes. Earlier it used to take days, but now only for international transaction you sometimes might take days. But yeah, most of the time the bank transfer, whether it's interbank within the same bank or within different bank, within India now it takes few seconds or maximum few minutes, or in the worst case few hours. But yes, mostly the transactions are settled on the same day. But yeah, merchant may be paid, uh, there could be reconciliation and the transfer to merchant bank account may happen on daily basis or on weekly basis as per his preference. So payment gateway takes care of settlement between merchant uh, bank account. So this is about high level architecture, or this is overall, it's not actually the architecture, it is how the data flows from one entity to another entity. And as you see, for making any payment there are so many entities this is which are involved. So this will just give you an idea of what exactly is a payment gateway. Now let's look into more of the functional requirements and non-functional requirements, because to design a system we need to first understand the functional requirements and then also understand the non-functional requirement. Just give me a minute. I'm just keeping my meeting also in the backgrounds and also just keeping it in front in case someone else join, then I will be able to allow him to the call. Okay. Yes. So yes, now let's talk about more in detail about the functional requirements. So if you see, first functional requirement is about money transfers. Then the other requirement is user will enter the details like what is the amount, and he can make a payment, and then the payment will be processed, right? So basically payment gateway provides an interface where you can enter the user amount, you can enter the amount, a user can enter amount of what the transaction, how much money to pay, and he can initiate the payment. There are few more features like the verification of bank accounts and verification of whether the transaction is valid or not, and then the transaction happens. In addition, if you look into Paytm as a system, Paytm does a lot of things. Paytm is also responsible for processing the bills, utility bills. For example, someone can pay utility bills like electricity, credit card bills, you can pay for insurance, more or less. There are many use cases. Fastag, for example, is another use case. Maybe we will cover the design of Fastag in some other system, some other class. That's also a very important system. And then you have a lot of other use cases as well, for example flight booking, online shopping, etc. But we'll focus on the payment processing part mostly. So This money transfer part, how does it happen, is what we will be focusing, other than so many use cases of Paytm. Now, if we come to the non-functional requirements, in non-functional requirement, you should understand that one requirement is the money transfer should happen instantly, in real time, right? Because as I said, it should ideally take few seconds. Yeah, definitely it takes few seconds. It can't happen in milliseconds because there are so many parties involved. We saw in the previous diagram that there are 5 parties. One is the user who is buying the item or who is initiating the transaction. Then there is a store, and the merchant, and then you have a payment gateway, and then you have a payment processor, and then banks. So there are a lot of parties involved, and the transaction has to be secure, because this is important. Your customer should feel safe to do the transaction with payment gateway. That's why they are coming here. And you should support various kind of transactions, which is you can transfer money between different bank accounts which you have, right? That's one use case. You can make transfer person to person. You can make transfers person to merchant as well. So you can send money to your friend, and you can send money to a merchant also when you are doing online transaction. But yes, for any other expenses also, you can share money to your friends and relatives. So these are various use cases. So basically, these are variations of use cases. I will not say the second point is a non-functional requirement, but it's kind of a different kind of integrations, different kinds of parties which needs to be supported. Then QR code scanning, right? This is also another important requirement. Let me just remove this from here. This is still, we are discussing some non-functional requirements itself. So right. So yeah, we are still discussing, these are some of the functional requirements, QR code, and then we will be also having some features like reporting, which would be needed by the merchant to see the sales report. That means how many sales per month has happened, etc. And there should be some features for preventing fraud. So fraud detection is another important use case. This also involves analytics, and then figuring out any anomalies or any behavior which could be fraud. Right? Payment gateway should also be integrable to the e-commerce site, and there could be some customization, branding also possible on the payment gateways. So these are some of the functional requirements. And now let's go into in-depth into more of the non-functional requirements. So first foremost, we covered few in non-functional requirement, which were around the performance and security. So definitely performance is important, because you will not only have few customers, you will have millions and billions of users. So you need to able to perform high volume of transactions, and it should be fast even if the volume is high. By fast means low latency, and quick response and feedback to the user should be provided. Next, what we need is scalability. So you will have to scale up and down based on how many users are there on your platform. And then platform should be highly available, because if the platform is not available, then the merchant will not be able to process payments, and customer will lose trust. So it should have minimal downtime, and definitely high availability is required, and it should be fault tolerant as well. So any errors, it should be able to recover from it quickly without any disruptions, because this is what is required for a high available system. High available system needs to be fault tolerant and should be able to recover from the disruptions, recover from any failures very quickly. And definitely usability is very important, because this factor is the key factor, because you have Google Pay, Phone Pay, many competing applications, Paytm, and each and every platform is trying to become as much user friendly as possible. Because if I give you the background, earlier there was net banking. Now with net banking, that was the problem, that the usability was not that great. But now, no, with the latest technology, even with government initiative, lot of facilities government has provided, so you can do transfer very quickly and without entering much detail. You may just have to enter the mobile number of user, and you can get the money transferred to the person. No need to remember the bank account number, no need to remember IFSC code, etc., and more details, because earlier it used to take a lot of time and there was always a window during which only you can transact. But now with payment gateways, you can perform 24/7 transactions, and usability is also very fast. In few, usability is of very high quality. You can in few clicks make the money transfer. So this is about the functional and non-functional requirements of payment gateway. Any questions on this?
I joined late. I had a couple of meetings.
Okay. No issues. No, I understand it. I am having this session during the weekday, so I
Okay.
understand this. But yes, I wanted to have this session earlier, because we have another session planned on Saturday, and I have some other master classes which I'm doing for some other some other institutes as well. Great. So we just discussed about the functional and non-functional requirement, and then we also discussed about the different parties which is involved in payment gateway. That you need a customer, you need a store, and store means you have a merchant who will be providing some service or goods, and when customers places the order, the store would be having some integration with the payment gateway. Payment gateway you can think of as a POS terminal. So POS terminal is also kind of a payment gateway. But yes, on e-commerce site like Amazon, Flipkart, you will have online integration. So when you purchase an item, the request is forwarded to payment gateway for payment processing, and payment gateway works with the payment processor. Payment processor could be MasterCard, Visa, it could be UPI, and then the payment processor takes care of settling the money transaction with the banks, and not the customer is paying, so money is deducted from customer's bank account and it will be credited to merchant bank account. So yes, it may happen instantly, or there could be reconciliation, because maybe merchant will choose that I want to pay get paid together all the amount on daily basis or on weekly basis, so that could be taken care by payment gateway, or he can get paid instantly as well based on his preference. But yes, usually no, payment gateways will also deduct some commission and then pay the merchant some amount after some settlement, which could be on a day, on a basis of some frequency, which could be daily or weekly. So this is about overall parties which are involved and how they interact with each other. And once the transaction is confirmed, the bank is the party which will confirm the transaction, and at every stage there will be checks which will be done so that it will ensure that transaction is valid, and confirmation will be sent to payment processor, then from payment processor to the payment gateway, and then to store, and then finally customer will receive the message that transaction is complete.
So one question, Tarun. So this is more like POS, right? POS is like, so how does a QR code so when I scan my mobile, right?
Yes.
So from that, say that if I scan using Paytm or it may be even Google Pay, so it again reaches the same payment gateway within their system, and then it contacts the payment gateway provider, like Visa card or MasterCard.
Yes.
So they do the transaction with the customer bank. So say maybe ICICI or HDFC.
Yes. Yes.
That QR code contains the information to whom the payment has to be done, right?
Yes, yes, right. See, there are few ways. One is you can type in the mobile number and you can type in the amount, right? And you can say pay, and then the particular recipient will be paid the amount. And now, as I said, I told that one of the important non-functional requirement is usability, right? So to improve usability, now the other alternative is you just scan the QR code. When you scan the QR code, you don't have to type anything. You just have to use your camera, and the QR code contains the two information, which is the money, the amount which you need to pay, and the phone number or no, the detail of the party which needs to be paid, right? So for example, if there is some number which has to get paid, right, then both these information will be there, right? So QR code is nothing but a graphical representation of some data, which could be some fields, set of data. And I'll give you an example. If you want to play around with there is a QR code generator as well. So there is a tool, online tool, which is QR code generator. This is the URL for it. You can play around with it, and you will see this is the URL, QR code generator, right? So QR code is nothing but the graphical representation of text which you are saved from typing, right? So I'll just demonstrate that very quickly. So here in the QR code generator, QR code could be representing a URL, or it could represent various kind of information as well. So here I have chosen free text and say assume I want to transfer rupees 100 and to maybe phone number, right? This so when I type in these information, automatically I get a QR code generated here, right? So if I modify, or I can add more details, like say for example some message I need to say. So see, the QR code is getting generated in the real time, and this is I'm just saying, say some text that expense, right? Something like this. If I'm transferring some money to some phone number, and then if I'm sending some message, all these information, I can, rather than typing in, I can just scan a QR code through my camera. And once
Yeah.
I,
So yeah,
yes,
one question, Tarun. See, if I so when in the merchandise shop, right? So
yes,
display that QR code, right?
yes,
So it tells that you can use UPI payment, right? So that means that QR code is generated by UPI and given to the merchandise, right? Or it is a
the
common
generated
algorithm
by
which
a app,
Google,
yes,
yeah.
right. So the QR code is generated by the app, right?
Yeah. Then they should use a common algorithm in generating, right? It may
Yes,
be
yes, absolutely, absolutely.
the right process. Okay.
Yes, right. Because now the QR code has been standardized, so you can use phone pay, or you can use various other apps, Google Pay, Paytm. You can scan it with anything. So it's standardized. So the format is standardized for the QR code.
So, Tarun, one question over here. I mean, basically, I was. So, when you say QR code, right? So, QR code is not basically, it is kind of input to the payment gateway. Is it?
Yes,
So,
absolutely.
so payment gateway basically starts after you. So I mean, the role basically the behind the scenes or the back end processing for the payment gateway basically starts after the customer submits either a QR code or a UPI or any other input, right? So basically, it will connect to. So what exactly is a payment gateway? No? It's kind of a service that the bank provides, or is it's a kind of app that is installed on your mobile?
Right. So the payment gateway is a service, is a IT service, which is a third party service. It's not provided by the bank. Some bank may have no, but yes, it is an independent entity, or it's a mediator which will take care of processing the payment between different bank accounts. Right?
Okay, so the reason I asked, right, it's like, see, we have a lot of applications, right? So even you have a Google Play Store, you have Google Pay, or any other app. Basically,
Yes.
Amazon being the most famous, right? So
Yes, yes. Apple Pay,
almost
you
all
can
the
also
apps.
think of like.
Yeah, so basically, what when they use, right? So they will say something like, "I have configured payment gateway in my app."
Yes, yes.
Right. So the app is basically using the payment gateway provided by the third party entity.
Correct, correct. Yes,
And
yes,
as
absolutely.
a user, I'm going to or the or QR code as the input.
Yes, yes,
Okay,
absolutely, absolutely. So, yes, I'll
got
give
it.
an example. Say, Amazon earlier used to rely on some other payment gateway, right? But yes, now they have come up with Amazon Pay. So, generally, payment gateways are required because they have to follow some compliance guidelines. So there are strict security guidelines and strict compliance guidelines for storing any credit card information. All these informations are very sensitive information. So generally it cannot be, say for example, if I am just an e-commerce site, I may not have all the know-how to implement this security and standardization which is required for processing the payment. So what I'll do is I'll take the help of a payment processor or payment gateway. Payment gateway is a third party service which will also have various kinds of integration. They will integrate with various credit cards, debit cards, they'll support net banking, they will support so many modes of payment, which if I am just building a website for myself will be not able to do, because that kind of integration will require a lot of effort. And the other thing, even after if I do these integration, I might not get the trust of the customers so that they can pay me and put their credit card information. So that's why we need payment gateways, so that no people feel safe, they can use, and it can provide good good transaction processing, right?
Okay, yeah, got it.
Right,
Thanks,
and
Tarun.
yes, and
Yeah.
now RBI in India has taken a lot of good measures. For example, they have created a platform called UPI. UPI, you can think of, is again kind of a payment gateway, and also QR code has been standardized by RBI. Also, they all the QR coding mechanism is standardized in India, so you can use any app. Uh, right, what whether it is GPay, PhonePay, Paytm. Earlier, it was not the case. People have to scan and they have to use a particular QR code which was specific to the apps, but now it is standardized by RBI. So everything is regulated, and there are strict guidelines because of the criticality of these transactions, because these involve money, and there should not be any discrepancy, because otherwise people will be losing money, and there will be chaos, right? So this is in general the background about why payment processors or payment gateways are required. Now, next, let's move forward. Any further questions?
No.
Okay. So, yeah, this is in general the basic idea. Let's get into the design, right? So, if we look into the design of these systems, you will need lot of modules, right? So, for payment gateway, you need a UI, right? Sometimes you may have mobile app also, right? Because what you need to do is, first thing is you need to authenticate the user, and if user is authorized, authorization is also done. So for example, if you are using Paytm to make any payment, what you need is you have to create your user, you have to register your mobile number. Your mobile number will be verified using OTP, because automatically it will detect your SIM card. It will ask you to enter your mobile number, and it will send OTP for device verification. And once you do the device verification, it will automatically contact the UPI infrastructure to figure out what all bank accounts are linked to the mobile app, and then it will ask you to no it will onboard you. It will ask you to choose a bank account, and that bank account will be linked to the app. So you have authentication and authorization requirement. You also need KYC requirement, because you have to submit your Aadhaar or PAN card. This is again a government regulation. This is not a technical requirement. But yes, once you do this, then you are authorized to do any transaction. And next time when you log in, you just have to enter your mobile number, and some verification will happen, which could be password based verification, which is authentication now in this case. So you'll enter your password, it will check whether the password is valid, and if it's valid, for additional security, it may ask you biometric verification, which could be face detection, or fingerprint, or it could be OTP. And once
Yeah,
you
so
enter,
one question
yes,
here,
yes,
right? When you see almost all the apps nowadays ask for biometric, right?
correct.
Basically, biometric is not stored on Paytm or anything, right? It's stored on your device itself, right?
Yes.
So how does the app knows that you have authenticated? So is there once you
Right.
you give
Yes.
your biometric information, and
Correct.
the email tells okay, so the app reads that information at that
Yes.
point of time, and
I would like to add into this.
Sure.
yeah.
Go ahead.
So basically, in Android is an event-based system.
Yeah.
Whenever your application will raise an intent to authenticate via biometrics, okay.
Yes.
Once the user has input his biometric and it is authenticated successfully, Android system will raise an event and it will say like authentication successful or something, and then your application listens to this event and then it opens up the next screen. that my
Yes.
application is
So
successful. And if,
basically it opens up the next page, right? Or
yes,
what do you
exactly.
call it? It's page, right?
Yes.
Okay.
Yes.
So
Right.
it skips the authentication of that page and moves on to the next page
Yes.
in the
Yes.
app itself, right?
Yeah.
Mohit? Or...
Correct. Yeah. Mohit, go ahead.
Yeah, that's all for now.
Okay, sure.
Okay. Okay. See, yeah, this is similar to like, you have say identity provider, right? There is a trust between different parties here. So say for example, when you are logging to any website using Google or using Facebook or using any other identity provider like Twitter, so there is a trust between two applications, that if I am logged in successfully into Google, then other sites also trust that this person is the same person which is authenticated by Google. Same way, the Paytm will also trust that this person has been successfully authenticated by the owner of this device, and this device has been verified by me earlier, and if this is authenticated successfully in the device, then it allows simply, right? So this is how the authentication works, which is trust based authentication. And there are two things. One is app access, so it's kind of you have a additional security on your mobile which prevents user to steal, no to lose your information if your device is stolen. So there are two things. One is app will have authentication, and there is always trade off between security and usability. So you would like to log in, keep the app in login and authenticated state, but at the same time you don't want to lose your money if someone takes your mobile, steals your mobile. So you have a device level security as well. So you have security for two levels, and this helps you not to keep logging in again and again, because maybe you will enter your password once and then you will be logged in for a month or for 15 days based on know how the platform is configured. And if you are doing transactions, your session is always getting updated. If you are inactive, then you may get logged off, or for security reason you will be asked to enter the password again. Right, so this is one important module, so which we discussed in detail. Other important thing is all the information which you are storing, for example your credit card number, is to be encrypted, and all the information which is you are sending to the payment processor, that also need to be encrypted, because yeah, that information, this is your information which is for which is stored, these needs to be secure, and information which is in transit, that also needs to be secure.
I would like to add something to it.
Sure,
Tarun.
sure, go ahead.
So,
Yes,
so
definitely.
recently, RBI has added tokenization of cards to all the vendors. So
Okay.
it basically says that you do not no longer need to store the entire credit card information or debit card information on the device or in the account. So what it does is the vendor can authenticate the card with RBI, and they will provide you a token in against this card number. So
Okay,
you
okay.
so you can
Great.
use this token number to transact.
Yes,
Yeah,
yes.
so it's more like your Google Wallet or Samsung Pay you have, right?
Yeah,
It
no,
follows the same concept.
yeah, it should be a token against card on every different app will have a different token for same card.
Yeah.
Yes, yes. See,
So
this
you
is.
have 10 cards, then it'll have 10 different tokens for each card.
Yes,
For the same card, if you go to a different device, then it'll have a different.
yes.
Yeah, I worked in that for Bank of America.
Oh, great.
Okay, okay. Nice, nice. Yeah, this great input. Because I also see that this is such a nice initiative by the Reserve Bank of India. Earlier, people used to have digital wallets, right? Digital wallet was used because you can keep some money into the wallet, and
Yep.
then this could be used for transactions later, right? But then the problem was, you have to keep your money in different wallets. For example, Airtel will have another wallet, and GPay, PhonePay, Google Pay, even Paytm, they had different wallets. So yeah, there were other as well, like MobiQuick, right? Something, other, so many other platforms were there. So
Yeah.
now the need of digital wallet is also not required, because you can kind of, with the tokenization, get the money transferred without having to re-enter the credit card details again and again.
Yeah.
So this is an initiative for usability, and which is resulting in adaption of the usage, right? Probably this is to encourage more transactions and making things smoother. One such initiative we talked about earlier, to transfer money you have to use net banking. That means you have to remember the account number, you have to remember the IFSC code, lot of other details, like what are the bank account type, whether it's saving bank, recurring bank account, or what is current bank account, or what's the branch, etc. And then it used to take many days, sometimes hours and days. But now with UPI, you just need the phone number and the money gets transferred instantly. So this is
So,
about, yeah.
so one usage of tokenizing is that you prevent it against attack, because no one will, because that's because it's tokenized and it would be again encrypted.
Yes, yes,
Will not
absolutely.
have any information of the card details, so over the wire. So that's the
Yes,
reason, when I was in Bank of America, when we did it for Samsung Pay and for Apple Pay.
yeah,
So it was declared that bank will not share any credit card information. It will share only a token that would be stored on the device, and,
yes.
and it will be encrypted on the device and stored.
Right, right. Absolutely, absolutely. Because if you see that, okay, assume someone hacks the database of Paytm, right? And Paytm is storing all the credit card information. Then the damage could be a lot, right? A hacker can gain access to so many millions, billions of credit card numbers, and then it could be used for fraud or for illegal transactions. So this is a very important thing, that all the credit card information has to be kept encrypted and has to be kept secure, because encryption is only also one level of protection. It is not 100% foolproof. If I go into the details of security, yeah, there's a lot of things to cover, because you need to generate a encryption key, and encryption key needs to be rotated, and then right, the encryption algorithm should also be secure, because many encryption algorithm has been deciphered or has been violated by hackers. So yes, best thing is not to store the information in multiple places, because this will lead to more uh, uh, vulnerabilities, right? So now, next thing is, once you have all these information, you have to send the information to the payment processor, right? So this is another feature of your mobile app. And then you have merchant integration, and we discussed about security as well. And then everything will be also stored for analytics purpose, and for reporting, this will be used for reporting, and can also be used for, and generally now, fraud detection is important thing, which has to be supported by all the apps. So all the apps, they do support fraud detection as well. So you have lot of information which is stored. You have information which is about the payment, and you have information about credit card. You do enter, and they do, sometimes they may not store it permanently, but they have to deal with it. So they have to ensure that credit card number, credit card's expiry date, and CVV code is all encrypted whenever it is sent from the UI, right? So all the sensitive information has to be encrypted. So yeah, now if I go with the database design, that's very simple, because if we consider the low level design for such systems, you'll need user table, you'll need maybe a KYC table, right? And this is one-on-one relationship, right? KYC, maybe for user you will store ID, name, email, etc. other details. KYC, maybe you will have here the ID could be the foreign key, basically it's user ID and PAN or Aadhaar card number. And you will again have one-on-one mapping, because at a particular time you will have one KYC for a particular user, right? So this is one database design. Other one, you may have wallet, and wallet will have the balance as well. So it will have ID, balance, and last updated time. And then you may want to index this also with user ID. So this is in general the database design. But yes, not we there is one more important thing, which is what kind of database to use, right? Merchant also will have lot of information like email, bank account, and maybe one merchant will have one bank account, right? So I'm just keeping bank account as a single bank account, but yes, you may have a bank account table also, where if you want to provide facility of configuring multiple bank accounts for merchant, but merchant will always have one primary bank account which will be used for settlements. All the money which will be paid to merchant after deduction of commission from the payment processor will be credited to merchant bank account. Then you will have a record of transaction history, and then you will have also various payment methods which will be supported, right? And then you will have to keep detail of various bank accounts, banks which will be integrated with the with payment gateway. So a lot of information is to be stored here. So this is in general the kind of information which will be required to be stored in any payment gateway like Paytm. Now here we should also understand that this is both read heavy as well as write heavy system. So we have to optimize the database for both read as well as write, large number of read and write. Now let's discuss next thing, which is most important part, what kind of database to use, right? Because there are various choices here. You have,
Yeah.
yes, go ahead.
Yeah, so I would tell, because it's a very simple database and it's going to be more of the millions of customers are there going to be, so relationship database is enough. And you can use Postgres or
Yeah,
Postgres
right.
should be fine.
Okay.
I would not recommend NoSQL until you really need a strong point for NoSQL database.
Yeah. Sure.
I think millions of customers can be handled by today's RDBMS databases.
Right.
And the other point is you need transactions to be maintained. And so apart from your user information, your other like your transactions, your reconciliation report, all these have to be it has to be two-way commit databases.
Yes.
It supports because it's very critical that you make entries, you roll back everywhere,
Yes.
or you don't make an entry. So it's very important.
Yes.
But yeah, I think probably you can use Gigabyte DB also, so
Yes.
which supports transaction nowadays. So it lies in between your
Correct.
NoSQL and your
Correct.
SQL.
Yes. Because yeah, you can ensure transaction transactions in NoSQL databases also, but again it's about know how easy it is, because relational database are optimized for transactions, right? And they support this out of the box, but then definitely you can ensure through various mechanism transactions, because it's just about having rollback. You have to start the transaction and maybe you want to keep some checkpoints, and if some failure happens then you roll back to the previous checkpoint or start of transaction. So that could be implemented in various databases. And yes, so let's know, I will give you the approach how to decide, and this is a more systematic approach, and this we will do using back of envelope calculation, right? So let me give you in depth how this decision is made. So first thing is you have to think about how many users are required. So you will have say 500 million users in Paytm. In big payment gateway, for example Paytm, it has roughly around 500 million users. And let's assume that every user is doing 10 transactions per day, right? This is on average. Many people will be doing many transactions, but let's say no. Let's assume not 10 per day is very high. I would say you don't do transactions every day. Maybe you do 10 transactions per month, right? That looks more reasonable. So you have 5 billion transactions per month. This is the volume of transactions. Now, when you do any transaction in Paytm, there are multiple queries that needs to be done, right? There has to be a query which will figure out what is the bank account, because from mobile number you have to find the associated bank account detail, and then that bank account detail has to be used in the transaction. So you have to find the bank account of the merchant, you have to find the bank account of the customer. You have to also insert this information into various places, say for example for fraud detection or for reporting analytics. And you will also make a record of all these transactions so that user can see the transaction history also. So let's assume for per transaction you have 5 SQL queries, right? Because exactly we have to really write the queries to find the exact number, but roughly one transaction equal to 5 queries, right? Whether SQL no SQL will again come, but yes, 5 queries will be required. So if you see here, we have 25 billion queries per month which will be done. And let's convert this to queries per second, right? Because that will give us an idea of how many queries per second will be required. So this is 25 billion divided by 30 days, and 30 days means 30 into 24 into 60 minute into 60 second, right? Right, so this is what, no, so this number I know, this is number of seconds in a day is
It's
this one,
6740.
right? It, I'll for simplicity round it off to 100k, right? So basically this is your total number of transaction is 25 billion, right? So I'm just writing this. 25 billion, this is 25 billion divided by 30 into 100k, right? So 100k, I am writing like this. So this, if you see, is coming to be something like this will come, right? Because this zeros, 6 zeros will be gone here. So it's about
It's
3,
around
25
7.
divided by 3, 25,000 divided by 3, or roughly it is 8k transactions per second, right? Now we can figure out that is it can it be taken care by relational database or
Yeah,
not?
AK and all, it should be able
Yes,
to.
yes,
So Postgres
absolutely.
would be able to handle
Right, right.
your AK transactions. Very easily it
Yes,
can handle.
yes.
Postgres is capable of handling
Right.
AK.
So you see, again, I'll give a range. Say generally 5,000 transaction, 1 to 5,000 write transaction. These are all write transactions because we have to uh, insert the information into, say, various tables. So even if it's a write transaction, you can take care of it because one database server instance is on a reasonable, again, machine size also is important. But yeah, if you have, say, 64 GB server and you have decent processor, maybe 8 core processor, etc., so you may take care of maybe up to 5,000 transactions per second, 1,000. Again, also it depends on how complicated is your queries, but roughly this is possible with Postgres. Finally, the decision should be taken after doing stress testing or load testing on the database. But yes, this looks like feasible in relational database. Now the other thing is data volume, because how much data you have to store, because relational database can be optimized through indexing, right? So let's assume we know these tables, that we have these information which will be written, right? So you have these tables, that's why I discussed this low level design. So here you see some text fields and not very complicated fields are there. These are simple text information, and we can assume this is maybe less than kilobyte, right? So whenever you do any transaction, you just need to store the amount, bank details, etc., etc. So there's no very data heavy intensive operation which is going through, right? So let's do data volume calculation. We know we need 25 billion transactions per month, right? So if we say that per transaction we have, say, 1k data, then this means that you need 2.5 terabyte of storage, right? So this is bytes, right? 2.5 terabytes of storage will be needed per month. Systems like Paytm have to store the information to some number of days based on the RBI regulation, because transaction record has to be kept and it should be available for at least 5 years. So your entire database size will be 2.5 terabytes into 12 months into
12.
5, right? 5 years if you want to store this information for 5 years. So it is 2.5 into 60, roughly you can say 125, right? Or maybe 130 terabytes, right? Roughly.
Yeah.
Correct. It's 150 terabytes. Can this be handled by relational database? Yeah, this volume is also manageable, because petabytes is something where you will be concerned, right?
Concern,
When,
yeah.
and then again, when I say that 5 years of data, I may have some disk storage. I need not have to store all the data in my single database. I may use some other technique where I have an archive data which is used for reporting purpose, but mostly I will keep the current data, which will be the current financial year or current quarter data, which will be in our active database. Most of the queries will be on the recent data rather than on the past data, right? So this, with respect to the data volume and with respect to the number of transaction, is manageable by relational database. So you may use relational database, but the performance is very important. And now we have to come up with the strategies to how to improve the performance, because what could happen, the performance latency could be slow, because right, what if it taking 2-3 seconds to process all these, so that we have to take care. So you have to use caching definitely, so to improve the performance of database. Now let's talk about total number of servers which will be required, right? So this is also another important thing which we'll do. We'll come back to exactly the database choice, and I'll tell you what has been used in most of the payment gateways, and then we can there are definitely no 100% right answers, 100% wrong answers, but what is being used widely in the industry, we'll discuss that also later. But yeah, let me jump to the number of servers needed, right? So we again have some data, like we have 500 million users. Let's assume every user is logging in or is using the Paytm app twice a day, right? Again, I'm making some assumptions, which is very important, because let's say you go and log into Paytm, right? You may not be doing the transactions every day, but maybe you are checking some items, checking your balance, seeing whether someone has transferred you money, etc. You may be doing some passive transactions, or you will just be viewing some information in Paytm. Now I have included 2 logins per day, because now it's usual, because it has flight booking, it has insurance, mutual fund. You go to Paytm for lot many things, right? For bill payment as well, credit card payment, lot of things. But yes, we will keep these things on the higher side. That should be better for estimation. Lower will be sometimes problematic if we design the system considering low scale. So I'm just putting 2 logins per day. And then let's assume when you log in, or when you just on average you make 5 API calls, right? It could be 10 API calls also, but yes, I'm just making some assumption that once you log in, maybe you are checking balance, so you may be calling 5 APIs. Yeah, go ahead.
Yeah, normally say that 500 million users, right, in a per day. So every time you make a payment, you log in, right? So it does not allows you. So I probably guess that's what it does. So each time you go to GPA or you go to any Paytm, it always asks for your biometric information, right?
Yes,
Or a
yes,
PIN code, right?
absolutely, absolutely, yes.
So that yeah, that was my question. So whenever you enter a PIN, right, does it actually reload the entire information from the server, or it just
Yes.
in the scene it is always running with the static information behind the scene? It's only every time the app comes into active state, that is when the biometric information comes in, or you
Correct.
really log in into the server.
Correct, correct. Yes, yes. Mohit, you want to take this? What actually happens? You have some insights?
Tarun, come again, please. I am
So
actually with.
the question is, whenever you go to Paytm or GPay app, you have to enter your biometric
Yeah,
information.
yeah.
Now there may be a lot of things which is happening in the background. Maybe someone has paid to you in the meantime, so you
Yeah.
just log in to check whether someone has paid to you in
Yes,
meantime, right?
yes, yes, yes.
So what happens when you log in, the application
No, that
reloads?
happens through Google Cloud push notifications.
Yes.
Whenever a user is receiving the payment, it will get a notification from Google Cloud Notifications API.
Yes,
And
right.
also, when you want to log in, you will check your biometric authentication, and then it will just trust the device biometric and let it in. And once it is successful, it will check for the token validity. It will store a token, and it will check for the token validity. Generally, these tokens are long-term validity tokens, so
Yes.
that we can avoid the traffic on login API at least.
Yes.
That is what I wanted. So
Correct.
it's
Correct.
basically behind the scene.
Yes.
That means the app is always logged in. It's only when it comes
Yes.
into active
Yes.
state, that is
Yes.
when the biometric kicks in and
Correct.
you
Correct.
authenticate it. It trusts that the other person authenticated, so it does not
Yes.
makes actual call to the server.
Yes.
Yeah.
Yes. You
Yeah,
see
right?
the information instantly, right?
Yes. Yes.
So in the background, it will be downloading information, any updates. Maybe if nowadays, they have games also. GPay has games, Paytm has games, PhonePe also have some coupons and lot of other engaging activities. So all these things get loaded and updated in the background. Only
Yeah.
it's, when you have to view some information or perform any transaction, there is a security mechanism in place. But yes, when you log in, only information, you are verified to use the device.
And also, in background, whenever we are making API calls, if the token expires, it just logs out from the app itself only.
Okay.
Yeah.
Great, great, awesome, nice. So yeah, you see here, this is our some assumption, like you have two times a user is logging in, and every time he is logging, he is calling 5 APIs. So that means you have 5 billion API calls per day, right? So you have 500 into 10, which is 5,000 million API calls per day, or 5 billion API calls per day. And then we know our one day is around 100k seconds, right? So 5 million divided by 100k, that means you have 50,000 API calls per second, right? So see, this is the volume of API calls which we need to handle. And let's make some other. So assume we have some medium sized servers. A server would be able to handle 10k, or even, right? And again, it depends how complicated are the API calls, how much processing power they need. But let's assume, right, 10k is also possible, but 1k API calls, assume we have a lot of processing required. So we have 1k API calls per second capability in one server, right? So you see here, you will need 50 servers to process these many calls. You will definitely need redundancies here, right? So because a call may be getting data from multiple systems. You may have microservice architecture, and there will be internal calls also, and these servers would be located in across geographies. So let's assume, if we have servers in, say, Mumbai, and some servers in Bangalore, some servers in NCR region, so like 3 servers you have. So you'll need overall 150 servers to ensure that your API calls happen as per the load of the system. Again, all the API calls will also be interacting with the database. So here, with this volume of calls, definitely here we need a API gateway as well, and you need to do load balancing also, because we can also segregate the calls, and load balancer can look into what kind of calls are being made. For example, if the calls are more for checking balance, see, there are different kinds of API calls. One is the financial API calls, which will be about transactions. Other will be non-financial API calls, which will be just checking the balance. And then there could be other classification also. For example, if you are just reserving some money for say SIP, right, or some investment, stock investment, you can buy gold, online digital gold, through Paytm also. So you can segregate these different kinds of use case and build separate servers, and load balancers can balance the load, and you can scale accordingly based on the demand at particular use case. So this way you can scale in more detail various servers. But yes, you would need multiple servers and multiple kinds of servers also, like web servers, you will have database servers, or you will have servers which will be application servers as well. So let me now give you a kind of a very simple architecture, right, of the Paytm app. This is the high level architecture, because we just got what all components we need. We also discussed what all modules we need. And now if I look into the architecture, high level architecture, I have already drawn it in advance so that I can discuss this during this session.
Sure.
So I'm just sharing this. This is the high level architecture. So you have a customer who will be in using various clients, which could be Android, iOS, and mobile apps or web applications. You make a call, API call, which goes to API gateway. Basically, there will be a lot of servers behind API gateway, and there are no, as the information is hitting, actually you will have encryption in the client also, but you need, basically, I would say encryption is also implemented in servers, and client is basically calling the servers and choosing the right in security algorithm, and data encryption happens here. But yes, same way authentication and fraud detection also happens. Whatever client is doing, it is also sending information to encryption servers, authentication and fraud detection servers, right? Basically, it's getting all encryption key, getting the encryption algorithm. Maybe it's not transmitting the data insecurely, but it is interacting with these modules here, right? And then if just considering the financial use cases, because otherwise the system will become very complicated, you'll have various servers. I should have drawn some server layer here at the top. This is what I'm going to update this, because your database will directly not communicate with the API gateway. It will communicate first with some servers, and it will store information, which could be user information, transaction information, activity logs. And your bank interface will be interacting with various banks, which could be merchant banks and customer banks, and which will be processing the payment and settlement will happen, right? So this is very simplified architecture, but will not work because we have very high scale. So now, as I recommended, because load balancer is important, API gateway can do load balancing. So, but yes, no, explicitly we can also have hardware load balancers which can do fast load balancing, and right, there may be some calls. So for example, say fraud detection, if we are using some external service, then that could be also such kind of load balancing, and load balancing between various APIs could be taken care by API gateway. But yes, you may need multiple API gateways, and you can load balance, place a load balancer ahead of API gateway. Right, so let me share the updated diagram. Right, so just I have added a load balancer also for improving the performance and scalability. Now here, when we talk about load balancer, we should mention what kind of load balancing we will be using. Any suggestions? What kind of load balancing should we use if we want to achieve high performance, fast response time, low latency? Then what load balancing will be recommended?
What do you mean by that? Because you have FI, you have Nginx load balancers.
Right. No, definitely hardware load balancers we will be going, but what load balancing algorithm? Like you have round robin,
Yeah.
weighted round robin, least connection. You can have high IP hashing, right?
Yeah, you basically need to have. That's because consistent hashing has to be used to make sure that you, because you'll not have one API gateway, you should have a couple of API gateways to
Yes.
route that information.
Yes.
But you should, basically you need to, all the requests that comes, right, you need to
Yes.
balance
See,
it and send it across different.
correct. To get high performance, you can have sticky sessions. So if you have a sticky sessions, or you can use IP hashing, right? And if your hashing is consistent hashing, then you will have maximum performance, because you can cache the information at the server level also, right? So your now, for example, if you are making transactions and making transactions to few of your friends or few of your merchants, then all these merchants are near your location, then very quickly these data can be retrieved by the servers, because if the same call is going to the same server, and even after no you if multiple calls are going to the same server, then this information can be quickly retrieved and processed. So this is what is generally used. Sticky session is used, and IP hashing algorithm is used. Now coming to next thing, what we can do is,
But one question before you move on.
yes,
Tarun.
yes,
One
go ahead.
question is, if you use IP based hashing means, so okay, so each time, but if you use IP based hashing, right, so your mobile network keeps on moving and the user can connect to the router or any network, right? So then the IP address keeps on changing, right? Or it should be more like a user based hashing
Right.
base, so that it routes to the same user.
We can use MAC address hashing as well, no?
MAC address.
Yes.
Okay.
Awesome. Yeah, that's even better suggestion, right? You
Yeah.
can use MAC address based hashing, or hashing which could be based on the mobile number,
Yeah, that is
right?
also.
Because mobile number will be unique. But yes, no, we need to ensure stickiness, and definitely there is always drawback that fault tolerance will be reduced if you have sticky sessions,
Now, so one question is, see, when all these products which go on cloud, right?
Yes.
And if you want to deploy on Kubernetes or anything,
Yes.
maintaining a sticky session is very tricky, and
Correct. Correct.
these systems, right? These infrastructures are built mainly for stateless machines, right? With
Yes.
and yeah, you're going to end up with a lot of complexity, right?
Yes. Yes. Right. So yeah, because the problem with the sticky session is that the distribution may not be always uniform, right? So that's one problem. Other problem is maybe the fault tolerance is less because the distribution is not uniform. So you have you need to have some mechanism to recover. But for API gate for payment gateways, performance is highest priority. Security is the highest priority. Next thing is the performance. High availability, fault tolerance may be the third priority. So that's why stickiness could be used here to achieve high performance. Now, next thing is, so this is improving the performance for the servers. What can we do to improve the performance of the database? Right, so database could be a bottleneck, and we need to improve the performance here as well.
So basically, your read should be a non. It should be like you should have a denormalized table, whereas your writes only go to your normalized tables.
Yeah.
So that is one way of increasing your performance.
Yes.
That
Yes.
way is basically, yeah. So even you do replication, but at the
Right.
table level, you still
Yes.
need to have denormalized table.
Yes.
Read
Absolutely.
operation should be extremely fast, whereas your write operation should basically go to
Yes.
your main table and then does the replication. Yeah,
Yes.
so
Yes.
basically it does child table update and everything. So that's one way of doing it.
Correct. Correct. Yes. Absolutely right. Because first thing is you should have properly indexed table, right? You should have all the queries very well optimized, and with query optimization I mean you write queries in a way so that it performs well, and also your table structure is properly normalized so that the data could be retrieved well. And then if all this is done, this will be taken care by low level design, right? But then once this is all done, then you take care of it by having more master replication, not master slave, because you have write heavy configuration also. So you should have multiple masters, right? So multiple masters and multiple slaves is what you need. You have to distribute your writes across multiple masters and reads across multiple slaves, and then definitely you can reduce the load on the actual database by having a caching. Right?
Tarun, I have a question.
Yes,
So,
go ahead.
if we have multiple masters, how we can eradicate the sync issues?
Yeah.
Yeah. So the data sync replication can also happen through various mechanisms. One is the sync you do at periodic time and the full replication, right? Other is you can do the replication. There could be various replication strategies which could be in place, and what is recommended is the replication which is more frequently done, right? So you should replicate as often as possible, and whenever there is a change you should replicate the information. So this way, since you are doing delta replication, your changes, and you are doing frequent replication, frequent sync of multiple masters, this can happen very quickly, right? So this is one way of reducing the latency between the replication. Yeah, but this is right question. It's a challenging thing because, yeah, if multiple masters are there, then sync will take time and my
Yeah,
performance will
actually, I
reduce.
I encountered this issue while I was scaling my system to 500 TPS.
Yes, yes, you got it right. You caught the right issue,
Hmm.
and this is not the 100% foolproof solution. So this
Yeah.
is my initial design, right?
Okay. Okay.
So, but yes, but some way, again, actual load testing is important, and there should be testing environment set, and we have to measure what works, and but yes, we can start with some idea here. But now, after all this, is there any other bottleneck? Because we reduce the bottleneck here, we reduce the bottleneck here in the database by caching and replicas. Where else can there be bottleneck? See, these services will also be communicating with each other. When there is high load, these servers may not be able to provide the required throughput, right? You may get some data lost, or some communication may take, or some waiting might be required, right? Because if some servers are
Mhm.
already busy, and how will you ensure fault tolerance as well? That will also be a challenge, right?
So can we put the failing requests inside some message queue like Kafka or something, and we can
Yes,
retry once service is available.
correct. Yes, absolutely. Because you should not directly communicate with all these services with each other. Asynchronous communication is preferred, and some message queue will be required.
Mhm.
Correct? Yes. So now if you have very high scale, multiple clients, then you have load balancers, you have API gateway, then all these interactions between different services will be happening through message queue. You can not only have only failing messages, you can keep all the messages in the message queue in appropriate topics, and then these servers should be processors, and there should be multiple servers who will be picking up from the message queue, and they will also be writing this way. Even if some servers fail, you will not lose the message, and you will have very good throughput and performance with message queue.
Tarun, one more thing I can see as a bottleneck. Under high load, relational database tend to have slower write times.
Yes, yes, absolutely, absolutely.
So we can do something to prevent that as well.
Yes, right, right, and that is again you got the right problem, and this is again no, which will only come from experience, that yeah, this architecture may not work because when there are too many writes are slow because you will have too many indexes as well, and if you have millions of records, then write becomes slow because you have to readjust the index, and you will get into various issues. You have to housekeep your database also because you will have deletes in the database. You will have to auto vacuum. You have to reindex because your index, as more and more data is inserted, your index may not be performing well, so you may get into a lot of complication. But now I will give you the actual architecture, right? This is we also discussed this architecture in one of the previous session. This is inspired from, or this diagram is how it is implemented in UPI, right? Paytm architecture, I don't know exactly what it is because this is their confidential information, but yeah, my guess was the previous diagram. But yes, this is from my sources, this is how the Paytm transaction, Paytm architecture could have been. So you have load balancers. Load balancers, you have active and passive. You have again servers which are distributed based on different use cases, and load balancing is applied using two algorithms. One is based on the content, it is forwarding it to the right servers, and then we are also trying to ensure that there are sticky sessions so that it could perform well. You have, instead of cache, in-memory database, because writing to in-memory database is faster than writing to hard disk. And when you have millions of transactions per day or thousands of transactions per second, in-memory database can save and perform very well. But now, to store this information permanently, you will have to move it to the database, which could be hard disk based database, right? And then no, if I have multiple masters, etc., again, then you said that problem is there, that syncing will take time and there will be latency again, right? So the solution to this is put everything in a message queue, right? And as these systems are processing the messages, you can update the messages, and then there could be a DB processor which can sync the data from in-memory database to some database which is Cassandra, and Cassandra is optimized for replication. So it has a cluster and it can be replicated in fast, and it has implementation of consensus algorithm so that it can figure out what is the most recent information, and it performs well in this case.
It uses Raft, right? Or it uses something else?
Cassandra, yeah, this is something I am also not able to recall, that what is the consensus algorithm. I think they will have multiple algorithms, and based on the configuration, they may use different algorithms. Because now, no, these.
It may use Paxo or it may use Raft.
Right, right. I see that no. Paxos is also used. Paxos consensus is used in Cassandra.
Okay, Paxos.
Yeah, for lightweight write operations. Right.
Sorry, what was the question?
What is the consensus algorithm used in Cassandra? Cassandra database, what consensus algorithm is being used?
I didn't get that. What's a consensus algorithm here?
Yeah,
I mean, what does that mean?
Would you like to take, Manoj?
No, consensus algorithm is nothing but so in a distributed system, right? So you have a write comes to one of the so it can be like, say for example, Cassandra, right? It uses a leaderless election algorithm. So one of the node acts as a master. The request comes there, then it sends a replication to other followers. So once they confirm things that they have taken the say that they taken the values, then again, once they send back the information, then the master node, which is acting as the current master node, would send out a commit notification to all the followers who have taken the current value. So after they write and confirm,
Okay, so basically, I'm not so sure, but I mean, is it similar to HBase?
no, consensus algorithms are like
No. Cassandra database and all. Is it similar to HBase? See, Hive basically works in, you write to a queue and one of the nodes will acknowledge, and then it will just, kind of publish it to a queue saying, I've stored one replica, and so other two nodes will basically, take that particular message, create their own replicas and update it to the master. But I'm talking about edge based over here. So edge based, it's more or less like, you create shards and all, if at all I'm not wrong. But the way it distributes is, I think it's I'm not so sure how the replication works, but it should be similar to what we have. And it's more of a fast read and write, right? Cassandra. It's not like Hive. Hive is like more of a data warehouse kind of thing rather than
Yes.
a real time thing.
Yeah, I
Yes.
think as per Martin Flower, right? He is one of known architects in the distributed world. So he tells Cassandra uses Paxos algorithm.
Yes, yes, right. See, Cassandra is a database which is optimized for heavy reads and writes. It has basically multi-master architecture inbuilt. So when you create a Cassandra cluster, you get multiple master nodes, and data is replicated across multiple nodes, and the replication is very efficient. So for fault tolerant systems, and wherever you need high performance with respect to high number of reads and write, Cassandra is the database which is recommended. And yeah, it has a consensus algorithm. If it reads from two replicas and it finds information is mismatch, it will try to use Paxos algorithm to figure out which is the most updated information, right? So
Yeah.
generally yeah.
Even VAS, right? Windows Azure Storage uses Paxos.
Okay, okay. Yes, yes. Sure. So yes, mostly this is about Cassandra, but yes, that is also one good idea for a session, upcoming session. Maybe we can have a session on Cassandra database. We already had a session on MongoDB, but yeah, maybe we can plan a session on Cassandra.
So Tarun, probably you can add one more block here for controls. So controls is basically when you so basically your authorization authentication type.
Yes.
So we have a kind of cascading permissions and roles, right, for the users. And I mean, this is from an end user perspective, but definitely the database would be federated and also segregated based on and data masking. So probably on the financial side, data masking is a big thing.
Yes, yes, absolutely, absolutely. I understand. But yes, in system design, we don't have to go too much in detail about the domain specific stuff. Because
Right.
yes, I have worked on all the PCI DSS standards as well, right? So there is payment card interface data security standards. There are a lot of standards which they have to follow, which has to deal mostly with the security stuff, and segregation of information and masking is also one of the important so you have reporting system, you may have logging and troubleshooting system, monitoring systems as well. So the architecture is going to be very complicated than what I have shared, and definitely for logging and all you would need masking as well. So but yes, also a lot of logging frameworks take care of masking also. For example, Splunk and all, these are the log processors, they can take care of masking as well. But yes, there could be more details which could be added, and this is very simple diagram to show basically how high performance is achieved. But yes, in a system design interview, if I directly give this answer, this may not be the appropriate answer. I have to walk through the entire process of how I come to this final architecture, and as I discussed where various trade-offs, right? So what are the trade-offs and what is my priority here? So first priority is definitely security. Second priority is low latency or high performance, and that's why I chose here these components, which is in memory database and Cassandra and message queue, which could be Kafka. And then there are various processors which will make the system fault tolerant and high available as well, and they will also make the system high performing by providing high throughput. So this way all my requirements, which are functional non-functional and non-functional requirement, is met.
Tarun, I can add one thing here.
Yes.
So if you see, we have in-memory databases outside the cluster, right?
Yes, yes.
So whenever we have high load, then outside of the cluster, traffic will have impact on overall bandwidth of the system.
So
Because in-memory
cluster, you mean what cluster?
for example, this is Redis.
Yeah, Redis clusters, right? These are the Redis
Yes.
instances.
So since the overall transaction volume will be really high on this,
Yes.
so, I propose you to move this inside the Kubernetes cluster so that we can have a lesser network latency and overall network load outside and outgress load will be lesser.
Oh, you mean Cassandra cluster or
Not
Kubernetes?
Redis.
Kubernetes is for containerization, right?
Yes, yes.
So it should be containerized, you mean?
Yes, this Redis should also move inside Kubernetes cluster.
Okay, but where is the Kubernetes cluster? Right now, I haven't shown that.
So these services might be in the Kubernetes cluster, right?
Which
These are
services?
dedicated
Which
servers.
services? The DB processor, settlement system?
No, the financial, non-financial, and mandate services.
Yes, yes, definitely. Yeah, right. These will be in the Kubernetes cluster. Awesome.
Yeah.
Correct, correct. So this should also be in the same network, right? You mean?
Yes, yes.
Awesome, awesome. Yes, agreed, agreed. Because this way you can have very fast communication.
Exactly.
Okay, okay. Awesome, awesome. So yeah, this dotted line, I should kind of make it go within this, right? And then the same will apply to the message queue.
Correct, correct.
And then entire thing should come in the same box.
So I would recommend if we have see the storage part, we can have lesser speed. We can trade off the speed here because if we have very large cluster, it will cost us very huge amount on the infra cost. So we can segregate these reporting things inside a separate cluster if you want.
Yes, yes. These could be third-party systems as well, right?
Yeah.
Okay, awesome, awesome. Right, so until message queue and in-memory data storage, they could be in the same cluster, right?
Right.
But the last two blocks, lower two segments, Cassandra and the systems, they can be in separate blocks.
Yeah, yeah.
To reduce the size of the Kubernetes cluster, because that will become otherwise difficult to manage.
Right.
So you will have probably these services may also be some third party services or external services as well, and this data storage could be a separate cluster. Yeah, I think Cassandra also does a good cluster management, so not sure whether that has to be in Kubernetes cluster or it could be also a storage cloud storage service, right? So
Right.
you don't have to then explicitly worry about managing the Kubernetes cluster associated with this segment. Awesome. Nice. Great inputs.